Okay. So I gave you the function definition last time. We did a brief overview. I think it was right before spring break. I feel like it was. Functions. Remember, we had the sets with the people and cell phones. Right? We said every input has only one output. Okay. Yeah, that's what a function was. So 2.3 is when they actually define it and talk about it. And you actually, we will. We'll try it. We'll try. But so you remember what a function is, right? Everybody?
Refresher would be nice. Yes.
Let me give you the definition then. So function mathematics assigns a set X to a set Y. Each element let me see, phrase this better. In the set X is assigned to exactly one element in the set Y. Remember, we said we have the set X is the inputs. Domain is the set of inputs. Call this X. So refresher. Range is the set of outputs. And we said a function assigned values in here to there. Okay. We'll use that last quick example with the numbers. 1, 2, 3 is sent to 2, 4, 6. So this function is essentially doubling everything from here to here, here to here. This is what F does. Okay, that can be anything. In math, we're going to use a sum function as an equation that sends inputs to some outputs. You guys remember now? So if any of these go to two places, it is not a function. So remember, we have people.
There's no exact order in which they have to go to the next one, but as long as that we only have one pair.
Yeah, every input goes to one spot. They're all paired. It's a function. They all could go to the same spot. That's okay. But
technically they're also going to one. So
so it doesn't violate the definition. So as long as each one goes to one spot, we're good. But if you see an input go branch off to two spots, not a function. The function relates inputs in a set X to outputs in a set Y. The function can be anything. It doesn't have to be in math. Right? Or you could have a washing machine as a function. I input dirty clothes and it outputs wet, clean clothes. So we have inputs and outputs, right? But I better not get, I can't get two different outputs from my input. I better not get, wet clothes and dry clothes. It's not a function. Doesn't make sense. It's gonna be weird. So anyway, the homework starts off by giving you examples and asking you, is this a function? Okay. If it's not a function, then it's just considered to be a relation of two sets. Okay. For example, circles are relations, but not functions. There's a whole field of mathematics just talking about sets. Determine whether the relation is a function. Statistics uses sets, but it is its own mathematical field. Like set theory is pure math. But it is very useful in stats. Okay, but like, have you guys heard of SQL, the database language? Like,
That's for coding, right?
it is using coding. It is a programming language. So like the language is basically pulls data and creates arrays. Okay. So like, let's say you work for HEB and there's a database. You say, I want all the data on customers that showed up at this zip code or at this date. So SQL would be the sets. You would input the language, and it would create intersection of each of those groups. So I can find out, okay, I know what they bought on this day, at this zip code, at this time, whatever. So you can create a relational algebra. Okay, that's SQL. But anyway, a relation in general, just a set. So this is a set, and that's a set. Is it a following set of points? The set can be anything. In this case, it's a set of points. Is it a function? All your X inputs are your domain. All the Y outputs are your range. So it's like this circle and that circle, the X's and Y's. So the domain, they didn't ask for it, but it would be 10, -7, 2, and 5. The range would be all the outputs based on those inputs. 5, -5, -1, -8. You see where they're coming from? So whatever C is, I don't know what the hell C is, but it's a relation that takes the number 10 and relates it to 5. So these are technically being related to each other as points. Okay, now the question was, determine whether this relation is a function. Does it violate the definition, or is it okay? Yeah, it looks okay, right? You don't see any X's going to two different places, right? Maybe your X did, but did this X, any of these X values go to two different places? Right? None of them repeat. We're good. You're good. That makes sense or no?
Right there,
Yeah, all these right here. Does everyone see why this is a function? It's okay. So if any x would have repeated itself and gone to a different place, then you would say right away, no. Like if you had seen a 10, 5 and then a 10, 2, that would violate definition. Would not be a function. All right, I'm gonna turn the page in a second. Yeah, when it comes to like math functions, x will always be the inputs, the x values, yeah, the domain. So if you remember the definition, you should be good. You can also graph it if you have like a actual function. And you'll see it. You could graph the points technically, I guess. And if you draw like a vertical line through it, if it hits more than one time, it's not, it violates the definition. So if you would have plotted all those points on a graph, and if you see that a vertical line hits 2 points, then it's out. Right, I'm gonna turn the page. Any questions on definition? An input could be anything. No, I mean, you could have a function that's not numbers. Could be some inputs. Depends. But here we're mainly going to stick to points.
table and it's going to be last time, so it's there and very.
All right, is the following a function? What is the domain and range?
Yeah. Oh, what is?
Is this table here a function? Why not?
Yes.
Because nobody created two different values.
So right there, this violates our definition, right? But we can still mention the domain. What's the domain?
1 second.
1,
Yeah. Oh.
all the x's, right? Okay, y 7. Notice how I have 8 listed twice.
5 listed twice.
Should I write it twice?
No.
Oh,
So when you have a set, set is just listing elements, right? If I have a set of people on a list, if I list the same person twice, does that make sense?
No,
It's still the same elements, right? It's still the same person. I mean, yeah, you could have two different people with the same name, but let's disregard that. If you had
Can't have two people.
list of people, the same name, it's the same element. Yeah, so if you see something repeat, it's still the same element.
When you do it, you don't write it.
You're not,
So the top, you don't have to write the top. -3.
the -3, it's this one, yeah, that's wrong. I mean, you could write it, but it is unnecessary. And it's kind of weird.
And you don't have to write the 8 either.
Nope.
So it's
One time.
-2.
This 8 is this 8. That's an input. So over here, I should only have inputs. Only X values. Range would be here, all the outputs. The vertical line test is a test that shows graphically if a graph is a function. Should I phrase that? No vertical line should touch the graph more than once. If it is a function. So you just draw random vertical lines and see. So for example, draw you a picture. Is this guy a function? So if you draw vertical lines through it, you should see them hitting twice every single time, right? Not a function. It fails the vertical line test. So those inputs have two outputs. that person has 2 cell phones. Okay, let me look at the workbook. I haven't messed with that in a while. Turn to page 112. Do 1 through 6, the next 15, 20 minutes. Say 15. 112. 1 through 6. Okay.
We'll go back and that's probably like one from her.
I think we only eat one anyways.
No, shit's expensive.
Okay.
Still, I think, wow, for the-
So we're talking about domain. Look at the lowest X value. So right here, this is, let's say it's 1 because it's hard to tell in the picture. That's the lowest one. Keeps going forever. So the domain will be starting at 1.
Isn't that supposed to be a 5 or a 6? 1, 3, 4, 6. I didn't know it would be skip numbers there.
Oh, I bet. I don't know how to count. I don't know if you know that.
Oh, man. He's like, I just pretended to pass my class. I'm the teacher.
Yeah, I use Chat GPT. Okay. Is that right?
No.
What's wrong with it?
Well, we have a 10. You only have 6.
It goes to infinity.
There you go. That's what I want to hear.
There we go.
It goes on forever, right? Because the graph will keep on going forever. The lowest point on the X is 1. So the domain starts here, goes to there. So from here to forever. Technically, this keeps going. Now the range, look at how high and how low it went. It keeps going down forever and up forever eventually. So the range is all real numbers. Okay. Does that make sense? Any questions on 5? I know it's a poorly drawn graph, but. Is it a- Yeah, it's always assumes it keep going. Unless they put like a solid point. If it has an arrow, it's assumed forever. Same question, I'm gonna repeat it. Okay, so over here is the number 6. I believe these are number -1, -2, etc. I'm not gonna write it because it gets messy. What is the lowest x value? So -3 is the lowest one, and it goes all the way up until what's the highest x value?
The lowest X value for.
Right, the highest is 0.
Oh, yes.
Okay, for range,
Must have been in that order.
it's always smallest first and biggest second. Most negative or smallest. When I say smallest, that's what I mean. Range, what's the lowest value for up and down? Oh, looks like it went further. -1's right here, right? 2, 3, 4, 5, page 4. Look, did I draw it right?
Yeah, I went to -5. You're right.
1, 2, 3, 4. No, it looks like.
On the graph, it went to 5.
Oh, it did. I see it now.
It's just your line.
Yeah, I just can't draw. All right, can't do it all, right?
No, the line. The line. And not the dot, not the dot. There you go. Right. You are right now.
That's good one.
That's that middle line.
1, 2, 3, 4, 5. Oh man, you're right.
No.
That was close. I'm bad.
Yeah, we don't see the about it, leave it alone. Oh, thank you.
If you were getting TV. I'm just kidding.
Yeah, leave him alone.
No, I do like that one.
What's the lowest point we said? -5?
Negative 5. Don't need to combine it.
-1, yeah.
I got that one right.
That makes sense.
And it is a function of neither of the points.
Yeah, this is a function.
I was just a little. Not too sure if that was still like the way curvature they had to do that.
Oh, okay, fuck it up.
Or that's still technically be considered parabola.
It is a parabola, but since it hits twice, it's not.
Is it what? So what is-
It's technically has a parabolic shape, a function like a parabola.
We're at a way.
Parabola.
What is that? Is it? It's even nice. I don't know. Obviously, you don't know anything. Not that. Obviously, don't know.
Okay.
What did you say? What is it, English? No, no English. Right.
All right, you guys cool on 5 and 6. All right. You want to take a break?
Yes.
Let's finish these next 2 examples, then we will. You guys cool on this page though? Or no? Ruby? Get my ramen here. Same question. For Part A function.
You wrote that.
Did it while we were doing our work.
Skip that. Yeah. Cause now we're gonna do like 20 minutes. He's gonna be talking or like.
I'll wait.
He didn't want us to interrupt his drawings.
And now they're good drawings. Put some effort into them.
Yes, it is a function.
Yes.
Yeah, every line, almost every line is a function except obviously vertical lines. Any function that has a slope that's defined
Yeah.
is a function.
Okay, I'm pretty sure we're on the same page.
Are you on his page?
I've been on this page. Just like when you slow down and speed up. He's probably just passing me just because I participated in class, to be honest with you.
What the hell did we do? Sleeping. You just sleeping.
It's okay when I sleep, I learn the most.
Yeah, he has superpowers.
You know?
Yes. Wait, what is the relevance of y equals x?
Y equals X is is that line.
Do you really like my hand?
So that's the equation of the function
I love it.
or of the graph.
My brother had an interview yesterday or today. actually. And the one-
They are both functions.
Probably don't put the writing to be equal to the yellow.
I mean, that's the one I live by.
We can go to the website by hand.
Which is your H and B?
The one I'm going at.
Hmm.
I know. Do you know? Have a busy.
It's not, is it Southcross around there or a different one?
Oh, yeah,
Is it what?
Is it the one on Southcross?
Yes.
No,
South Cross and Pleasanton is the one that's that part.
South Cross and
no, I,
37.
no, I think
Yeah.
we're talking about the McCreeless market, the McCreeless, that's on South Cross kind of, South
Oh,
Cross
that's
and
the
the
one.
Broncos.
Yes,
Yeah.
that's the one. It's
No,
not-
I don't know the one go yet.
There's another one,
I
I
know
guess.
he asked you, is there another one around there?
Oh, yes, but.
So they're close to each other, right? Yeah, there's a.
Yeah, like 3 minutes away.
I remember seeing Goliad in that area. I just can't remember.
It's too good for that area.
I go there, they don't have no chips.
Well, everybody just. Everybody just next to him.
Well, that's why they're gone.
So many people eat chips there, I guess, that part of the time.
And then you go to the bread and it says only 2 loaves, there's a budget, like, boy, Corona is already, yeah.
Maybe that part of town just eats too much chips. They're trying to slow y'all down. They're worried about your health.
Right?
Like, yeah, I don't think you need more than 2 bags.
Yeah. Well, we can't even find the extra potatoes.
Oh,
Oh,
that's
you know, you know what? My brother, he used to work at Frito Lay. He said, the reason why extra hot Cheetos don't come out is because they always on the recipe. Yes. Yep. I bet you they even make those, you know, but they can only by accident.
All right, you guys wrote this down, is that what that means?
Trash. I said my brother.
So what's the domain for top one? What are all the X values it touches?
I would say -5
Oh, yeah.
and to infinity. Or infinity into infinity, because it doesn't really necessarily have a stopping point on the left side of the graph.
Yeah, it goes forever, it's true.
And I didn't even draw it. Look, where are my drawings at?
Yeah, and then you're gonna be okay.
Yeah, you're not using my notes, bro.
I just needed to figure out the first minute of each class.
What's the range?
I think otherwise.
Yep.
Same thing.
It touches everything, right? No problems here. Okay. What's the,
We're sleeping.
it's not good. What's the domain, Crystal? 0. It's gonna be bracket because it's right on there.
Okay, and then what about the others?
What's the lowest value for Y? Lowest one is still the same, right? Okay. I will, I will do, we'll take a break here and we'll do some different types of functions when we get back.
Okay, class will resume in 30 minutes.
Okay, you got 10.
I started to rethink the shake.
This small.
I was doing my fucking homework and he was like. I was like, I'm gonna serve on wellness and he's like.
Man, he has to do that at every single
Yeah,
time.
dude, I'm saying, you don't know already, but anyways, I was like, you did the teacher why? No, I was just asking, I was like, well, I'm just telling you, we were good teacher, and then he was like, well, you don't need any of this, I was like, please don't waste my notes. I need it. I was
We
like,
try
sure.
to jump on
Like,
top
he
of you.
was- He was looking like this, and I was like, if you can have a paper to write on, but please don't write. And I was like, what's this? That's what you did? You know, like this. Oh, yeah. Okay, well, you don't need any of that. No, I just don't even like talking to him, dude.
Well, he helps you, right?
No. He likes to sit there and criticize us.
No.
Yes, he does. You didn't hear him last time when he was like, what's your GPA? And we were like, something.
It's fine.
I don't know why he's doing that. It's weird. It's a chill out.
Yeah, last time I had told him, he was like, what are you going to school for? I was like, to be a lawyer. And he was like, oh. And I was like, yeah, I like to argue. I was like, so if you want to sit here, we could sure argue. I was like, but don't come over here and try to tell me what to do. He was like, well, I was just saying. I was like, no, I'm just saying too. Because he was like, well, what's your GPA? And then we told him, oh, no, that's not good. I was like, sir, are you here to help us or you're here to just talk shit about us? He was like, no, I am helping you. I was like, no, you're not.
It's funny. But not very nice. You're gonna go to St. Mary's or where?
I say yes, but I don't know for sure.
That's the only law school we got in San Antonio.
Yeah, well, it's because my boyfriend's going to the Marines, so we don't kind of know like how that's gonna play out yet.
So you might move.
Yeah, I might go try with him to see what school is a good law school up there. It sucks because I don't want to like sign up for a contract and then like he has to move because then I have to stay there and go to that school. So
Yeah.
I'm still like, I don't know, but if I do end up staying here, yeah, I'll go somewhere.
Study hard on that LSAT. All right. So for square root functions, you have to look at the inside and find out when it's greater or equal to 0. To determine when this inner part is greater than or equal to 0. So that's how you start. Once you've determined that, you'll know the domain. So for x, that'll be greater than or equal to -2, right? So domain is going to be -2 to infinity. What's it? If you graph it, you can also tell pretty quickly. Put that back in a second. So here's the function 2 plus x. So -2 all the way to infinity domain. Lowest point is 0 and it shoots up forever. So 0 to infinity would be your range. That's pretty much it though.
But the domain would be -2 to infinity, correct?
Mhm.
All right. That's it.
For rational functions, set the denominator equal to 0. And solve for x. So part B, you take that denominator, set it to 0. Solve for x, and that'll be x equal to 12, right? So once you've done that, you work around it because you can't have 12 on this one because it'll create division by 0. So this is the number it can't be. So your domain will be everything around it. That's all you got to do. So domain will be everything before 12 combined with everything after 12. Do we make a number line?
So number 12 wouldn't get a bracket.
Nah, as a whole.
Okay.
So after 12 is right here. Before 12 is right here. That makes sense. So anytime you have a fraction type, you'll do it this way. You can always graph it to check your work. So we put that function in there. Six over 12 minus x. See how it hits everything except that 12. It jumps over it. But the range looks like it goes all the way up and all the way down. But it skips one value. Do you see what it is? What range is not included?
10?
Range, right? The y values? But it goes all the way down forever and it shoots all the way up forever. But do you see a gap?
Yeah.
What y value is it not touching?
10.
0. Yeah. See, it hits 10 right here, 10 and -10.
Oh, okay.
Talking about Y values, right?
Oh, I didn't see what you were specifically.
So range is the lowest point and highest points. So lowest is negative infinity, highest is infinity, but it doesn't hit that specific value, it hits everything else except 0. So you have to create that interval. So for the range, everything below 0 is cool. Everything after 0 is cool. Yeah, for rational. When you have a rational function, you have to set the bottom to 0 and then work around for domain. Range will always be this type of rational expression will always have this type of range. If there's no x on top. Okay. Let me give you a note about notation. Let's say f of x is equal to some function. I'll move on from this question. Do you have any questions on number 4? A and B.
Or A and B.
A and B is number 4.
I guess sorry.
So-
Greater left.
So here's a function. It's a square root type. So anytime it's square root, you can't have a negative inside, right? So you take the inside and set it equal to or greater than 0. Solve for x. So this will be your domain. All x is above -2. So that's why I got this. And since it's a basic square root function, I know the range will be this. Because you have to remember what the original looks like. It's like the parent function. So I'm gonna send you a picture of all the original functions, and then all the problems in the homework are just those type slightly changed. Transformed. Yeah. They're called the parent. There's a list of parent functions. Yeah, B is a rational type. So now you have something, a number over x or something with an x on the bottom. You will always set the denominator equal to 0, solve for x, and work around that x value. So everything around is your domain. And your range will never have 0, so everything around that would be your range for rational, because this can't be 0 ever. It's never gonna happen. So it skips it. Gets really close though, infinitely close. So given a function, let's make one up. F of x equal to 2x squared plus 3x plus 5. I want you to note the following. F of x is the name of the function. F of x is also the y values. So if you see some notation like this, f of 0, that means you're plugging in 0. Okay. So plug in 0 to every x. So that's what this means. Right? It doesn't matter what it is. If it's in this parentheses, f of something, that means you plug it in. So if it's a w, we'll plug it in. If it's a triangle, plug it in. Or delta. That's the notation. If you see f of something, you plug it in for every x. Where f is the given equation here. Okay. All right, so for the rest of the, let's see, well. The triangle,
Like that a delta.
it's just something. The point is, whatever goes in there, you plug it in. Don't question it. Mhm. These would be this is your input, the 0. The work. And then the actual output is 5. So this is like your range value, domain value of 0. Here's just some random WM inputting, output is these 3 terms. Delta, these 3 terms. Square, triangle, whatever. Just plug it in, see what happens. Okay, yeah. All right, so on your workbook, finish the rest of those problems. Until the end of 118. So I'll let you work if you need help.